So you can see my screen now.
Yes.
Okay. And this is a sort of a whiteboard I use. So you might be using whiteboard in school, right? For school classes.
Yes.
So I can write here. Right. And then I can insert images or some text. I can write some text box. What sort of a software are you using in school?
For which class?
Or different for different classes?
Yes.
Okay. So you might be using something similar, right?
For class, most teachers already have a presentation that they use, and they don't really teach like this. Only my math teacher sometimes uses whiteboard.
Okay. So you are familiar with these things, right?
Yes.
Okay. Uh, you know Nandini, Mira's
Yes.
daughter? Okay. So you're also in Chicago?
Yes. Yes.
Okay. So this is a kind of so I can copy paste from wherever I require. So this is sort of question they have. So I write my response to like this. Like this is the question. So this is how I'll teach. I'll use this software and then I can paste whatever text or images I want, and then I can do my explanation using the pen. Okay, and I will
Okay.
record this session
Makes sense. Yeah.
and I will send the link to you.
Oh, okay. That's nice.
So it will be in YouTube, so you can watch it if you want it.
Okay.
So you have anything to discuss today?
Yes, I do. We
Yeah.
have an assignment for this weekend. Can I share my screen with you?
Yes. Uh, so should I give the control to you or you can do it?
Hold on. Let me see if I can do it. Does the host is the same participant screen share?
Just a minute. Something is not working. Okay, you can see the screen, right? Yeah, I think I'm sharing the screen. Yeah, so I can't see anything from you.
You're sharing the screen. If you stop sharing, you have to enable that I can share as well, because it says the host is disabled participant screen
Okay,
share.
I will
So you have to
stop
enable
sharing.
screen sharing for me.
So I have to give the
It
control.
still won't let me share because
So now can you share? I will stop my share.
you've disabled it in the settings. You go to settings and then enable so that I can share my screen.
Do what?
You have to go to the settings of the Zoom and enable that I can share my screen as well.
You can see my screen, right?
No, I just see you.
Okay, usually I don't give the control to the student. So what do you want to show? You want to show a PDF file?
No, it's a link. It's called Mastering Physics. We do a lot of homework on there, and I'm
Okay.
unable to share it with you. I have an account, so I can't like give you access to it, which is why I need to share my screen.
Okay. Can you try now?
Yes. Okay. Can you see my screen?
Yeah.
Yes. Okay. How will this work? I don't know why this isn't loading.
So is this an exercise or?
Yes, it is. Can you see it? Can you see what it
Yeah.
says? Okay, cool.
Listen to the photo heats and the time to the kids follows. Okay.
Okay, so we have to compare graphs. Yes.
Okay. Can you just go up to the table?
Yes.
Table, they are given the distance and the average time, right? So to get the velocity,
Yeah.
we have to divide the distance by the time. So 1.8 by 0.983, whatever. So that will give the
Yes.
first velocity. Can you just go down? Just hold. So this distance, uh, just go up. Okay, do you understand the question? What is the distance D?
It's just asking me to plot the average velocity is the distance. So we
Okay,
go
go down.
after this.
Go down. Uh, you can go down, right? Your internet is slow?
Hello? Hello?
Yeah, you have to share again. I can't control the screen, right?
No.
Okay. So first you have to plot this thing.
Yeah, you have to find the velocity first, right, to plot it?
Yeah. So divide the distance by time and create a third column.
Mm-hmm. Do you want me to do that for all of them or just some of them?
Uh, do some of them and then you can add more. I think you should do for everything. Otherwise, why will they
Okay.
give all these numbers? So first one will be 1.8 divided by 0.983, that one. Second will be 1.6 divided by
So I
this
got
one.
1.83.
So what is the
I got
value?
1.83, 1.95, 2, 2.06, 2.12, 2.16, and then
Yeah, you have to
start
plot
right
all
here.
those numbers. So
Mm-hmm.
5, 9 points, right? So you have to plot the 9 points on the
Yes.
graph and then see which one matches. Can you write on this sheet or
I can.
okay? Just plot on this first one where they have given the space. Can you write the numbers in this third column?
Sure. Just let me. That's all the velocities that I got.
Yeah, so just go down. I think the what are the x-axis? This they are not mentioned. They just put some numbers, right? 0, 1, 2, 3.
Yes.
Okay, just plot those points in this one.
On this graph,
Yeah,
this one, this one. Yes.
yeah, this one only.
Okay.
Okay, one thing is, see, it's almost constant, right? It is around 2. 2 plus something,
Yes.
2 minus something. So if you go down, something close to horizontal line is there.
No. Other than this is an option, but
But
this
but
is firmly at 3, so it's not going to work.
but it's increasing, right? From 1.83, slowly increasing to 2.17.
Yes.
So
Yes.
decreasing options, you can cancel it.
No, but this starts at 1.8.
Oh yeah, yeah,
So when you graph it,
yeah. Okay.
wouldn't it be like 1.8 and then it would go up, right?
It's going to go down.
So wouldn't it actually be a decreasing slope like this?
Yeah. So how many options are going down? Decreasing slope?
There is only one.
No, one
Just this
straight line is also there, right? So you have to
Yeah,
decide
straight line is there.
Yeah. So to check
But
whether
the straight line is only at 3. The straight line is firm at 3. So none of my velocities that I got are 3. So it can't be that one.
No, this option, the second option, is a straight lines but going down.
But it wasn't at a constant decrease. It's not a linear slope.
No, that's what you have to check. So one way to check whether it's straight line or not, you just have to find the slope here between the first two.
The slope, the difference between the velocities is not constant, just looking at the numbers.
See, this is
Would you
0.2
like me to
change in
write the
distance, right? And here also 0.2 change in distance. So here, how much is the difference? Velocity difference between the first two. How much is the velocity difference?
The first two?
Yeah.
0.12 is the difference between these
0.12.
two.
And what about between this one, 1 and 0.8?
These two?
Yeah, you can choose that also.
0.5. Oh, 0.05.
Okay, the next one.
0.06.
Are you sure? Okay. So it is not constant slope.
Yes, it's not.
So then it's not a straight line.
Nope.
So the only thing is a decreasing one,
has to have.
which is a curve. Yeah.
Cool. Which of the average velocities that you measure do you think is possible?
Answer key is there.
No, you have to submit it to get the answer key. Do you want me to submit this answer?
Yeah.
We got it right. There's the.
Okay.
There. Okay.
This is the same question or the next question, part B.
This is the next question.
Okay.
It's based on the same overall.
Okay. Same data.
It's the same type of, same data and same type of lab where you have photo gate here and here. You're trying to find this point. You're trying to find the instantaneous velocity of this point. You have a cart that goes through with its own photo gate, and you get how long it takes for it to go through a certain distance. So which of the average velocities shown here are the closest to the instantaneous velocity? Which distance do you think will give you the closest instantaneous velocity? Closest approximation.
Okay, just go to the top table, the first table. So this will give average velocity, right?
Yes. We found the average velocities.
Yeah, from that, how do you get instantaneous velocity?
I don't know. We haven't learned that yet.
See, instantaneous velocity means the time interval should become shorter and shorter. If the time interval is larger, then it's like average velocity. Okay, and the time interval becomes very
the
small.
shorter the distance, the shorter the distance, the more exact you'll have for instantaneous velocity, correct?
Which one is the average velocity that you measure? Do you think? Okay, just go to the one before you. Have they shown some diagram showing the photo gates?
No, but I can show you the diagram that we did this lab, we watched videos. So the photo gate is here and here, and this distance in the middle is constantly decreasing each time. And then you have a cart, and this is the path for the cart. The cart has its own thing, and every time it passes the photo gate, you start counting how many seconds it takes for it to go all the way to this photo gate. And this
Okay.
distance here is constantly decreasing every single time that you measure
How is it decreasing?
until it becomes 10 centimeters apart. Or 10, yeah.
Yeah. So when
Does
it
that
is
make sense?
closer to each other, then the average velocity will be same as the instantaneous velocity. See, average velocity is delta x by delta t, right?
Mm-hmm.
So when delta x is becoming smaller and smaller, it will get closer to, or delta t is getting smaller and smaller, that will become closer to instantaneous velocity. So I think the
Okay.
option, just show the option.
Oh, yeah. I submitted it. It's
Yeah,
correct.
I think you clicked the right one.
Yes, that's correct.
Okay.
Okay, next one. I don't know how to do this.
Extrapolate your collected data or use the graph to determine the instantaneous velocity of the glider through point x1. What will you do?
Point x1 is if the photo gates are here, x1 is in the middle. This is x1.
So x1 is the middle, right? So,
Yes.
and x is the displacement.
What do you mean? X1 isn't the displacement. X1 is if the photo gates are here, x1 is in the middle. You're trying to find the instantaneous velocity of x1.
See, according to the data points, you might have
Mm-hmm.
average velocity at this point and at this point, right?
Mm-hmm.
So if you take the average of those two velocities,
Mm-hmm.
it will give an idea of the instantaneous velocity at that point.
So I have to take the average velocity of all of the ones that we
No,
calculated for part one?
no, not average. Can you just go to that page? The
This
problem
work.
page.
Sorry. There you go.
Uh,
This one?
yeah, according to this, where is x1?
Okay. If this distance is 0.2, right? Like the last one here,
Okay,
then x1 is in the middle. X1
okay,
is at 0.1 distance.
okay. So what is the question now? I forgot the question. Okay, extrapolate
Find
your
the
collected data.
instantaneous velocity of x1 when the glider goes through x1.
So which data use then? Because d is changing, right?
Yes, d is constantly decreasing. You have to use this
So you
data.
have to
Find
use this last information, 0.2, because
this
that's
one?
where it's closest, right?
Yes.
So using this data, you have to find the instantaneous velocity. So yeah,
Yes.
so whatever average velocity you get with this data, that is should be close to the
Mhm.
instantaneous velocity.
So I just write the average velocity.
Just go down. I think it should be 0.2 divided by 0.9, whatever. How do you get this number?
So
Just go up. So this d is the distance between the two photo gates, right? So
yes.
when it decreases, the x1 is always in the middle.
Yes.
So if you use the smallest d, that will give the more
Mm-hmm.
correct value for the instantaneous velocity. So use this
Yes.
0.2 divided by this number. Okay, so no 0.2 by
So
this
then
one.
it would be
0.2 divided. No, what is 0.926?
That is the, oh, whoops.
It should be distance by time. So it's 0.2 divided by 0.09. 0.09, right?
Yeah, 0.9.
No, 0.09.
Yeah.
If you want to make it 2.6, you make it 2.7 because after 2.6 it is 9.9. Yeah. So what is this value?
2.157, so 2.16.
Yeah, that should be the answer.
What would the units be?
Just
Meters per second?
go to the table. What are the units they are given there? D is
They
measured
haven't
in
given
what?
anything.
What is the unit of D?
Centimeters, I think.
You have to know, right, correctly. If it is centimeters, and what is the unit of T average?
Unit of T average. That would just be centimeters per second or meters
Yeah,
per second. I think it's meters. I'm pretty sure it's meters.
okay.
We usually use meters.
Yeah, 0.2 means 20 centimeters. I think it should be meter.
Right?
Meter per second, yeah.
It's right.
Okay, but they are given 2.14.
No, they said 2.16. Oh.
But
Probably because I didn't use the whole number that they gave me. I rounded it off.
okay, but one thing I don't understand, they have said extrapolate, right? Extrapolate your collected data to determine the graph.
Yes.
Okay.
In trying to determine its t's velocity, what factors influence?
Are you measuring the speed by how do you measure the speed?
Oh, with the timer. The photo gates are attached to a timer where they
No, but
automatically measure. But these are all the things that could influence it if something were.
the cart is not moving constantly, right? You just move the cart and keep it at a particular distance.
No, we
Correct?
push the cart and it's on a slope. The cart is on a slope. So after we push the cart, it goes
Yeah.
down the slope.
But after that
It
you
increases.
stop it and then you measure the time, right? Or it's measured continuously.
Measured continuously.
Okay. Yeah, if the cart is moving too fast, then it's difficult to measure, right?
Is that all four, correct?
Just a minute. In trying to determine the incidence of what factors influence accuracy of measurement. If the acceleration is high, it will be difficult. Uh, yeah, should be correct.
Oh,
Okay, then remove the last one.
still wrong.
Okay, trying to determine the incidence of what factors measure the accuracy of measurement. Is it still wrong?
I didn't submit it again. I submitted it again without type of motion and it said wrong. I haven't submitted it without air resistance though. Oh, that's also wrong.
Okay, hold on. Interact with the incident what factors? You show me the what factors increase the accuracy of measurement. So incident velocity is the distance by time, right? So you have to measure both distance and time. So time and
Yes.
accuracy. So if the
That means both of these have to be there because they both matter. The
yeah
time
both
and the distance.
should be
So
measured
we tried
accurately.
without type of motion. Maybe we should try with.
Should be first three. Uh,
I
first,
tried that. Didn't work. That's why there's only 2 attempts left.
so you want to request the answer or
No, I want to get it right.
okay? But after 2 more attempts, you have to request, right?
Yeah. I don't think it's number 3 because look at the way that they word it. It says that it changes the value of the average speed, but you're trying to calculate average velocity. So maybe it's that one wording is why that one is not correct. If that makes sense.
Okay, you just submit this one.
No, do you want me to?
Yeah.
Okay. No. There's only 1 attempt remaining.
Yeah, I mean, I don't get this question. Okay, just try something and submit. I don't understand this question. Let's request the answer. Okay, remove the air resistance. Timer
I
accuracy.
already tried this. It didn't work.
Wait. Yeah, submitted.
Didn't we just submit this?
Yeah. Request the answer.
It's only that one? That doesn't make sense.
Hold on. In trying to determine the incident velocity, what factors influence the accuracy of measurement? Discuss how each factor influences the result. Placement of photo case if the photo case has to numbers that can change in D, and also changes in the value of average speed, timer accuracy.
It says only number 3 is correct, which doesn't make sense.
Yeah, I think you have to discuss with your teacher.
Yeah, I took a screenshot of the question. I'm going to email him.
Now, another way to look at it is the difference between average speed and instantaneous speed. So, suppose instead of this question is for average, right? Instantaneous. So, suppose you want to answer the same question for average velocity. What will be the options?
Then, if it's average, then the photo gate would still apply. Timer accuracy. Wouldn't it be all 4 of them? I don't understand why it isn't all 4 of them.
Okay, you ask your teacher. Okay, let's move to the next one. What other ways can the instantaneous velocity be measured directly, or is an instantaneous velocity always value? Radar gun is you can use.
I have no idea. I'm going to Google it.
No, radar gun means you see a moving object. If you shine a beam of light, it will get reflected by that object, right?
Okay.
So when the sound gets reflected, it will give the measure of the speed of that moving object.
Isn't this what police people use
Yeah,
to make
yeah,
sure they're not speeding?
yeah,
Okay, that means it has to measure speed, which means that
yeah,
it also works, right?
yeah.
Is these
Instantaneous.
two?
Yeah.
Correct. Okay, great. That's it.
Okay.
Got it 81%.
Because of the one mistake, right?
Yes, because we took 5 tries on that one question.
So right now labs are going on virtually, is it?
Yes, they are.
Okay. Yeah, actually lab things are difficult to tutor because I don't know what is done in the lab, right? I don't have the background.
Yes. For my next lab, I'll email whatever I get to you, so then you can look at it as well.
Yeah, if you have the PDF, if you email me before the class, one day before, it will be easier for me.
Okay.
So
Okay.
you
I
require
have your
help.
email, so I will.
So you require help with your class assignments, right?
Yes.
Okay.
At least for math and physics. It's a part of my grade.
Okay. So what are your school timings?
7:45 to 3:10.
Monday to Friday.
Yes.
Okay. So only we can have classes on Saturday and Sunday
Yes.
because this is my time. Uh, so what are the things you want to discuss? You want to discuss the assignments?
I want to do assignments, like homework assignments, and then also test preparation. That's the main things.
Okay.
Test and preparation, like review materials.
So homework assignments, you first you want to attempt first and then ask the things which you don't get it.
Yes. So for physics and math, it's two very different things. So for physics, this website that I showed you, that's where I do all of my in-class problems. So what I'm thinking of doing the next time we meet is attempting it myself. And if I get it wrong, I will have more attempts like we saw before. I get 5 attempts per problem. So I can come back to it with you and we can discuss it together. Does that make sense?
Can you send that thing before the class? That problem?
Yes, I can send you screenshots of each problem.
Yeah.
Does that work?
Yeah.
Okay.
Right. What about maths?
And then for math, most of it is I can do like my own problems and then come to you with questions. It's not a website like this, and I can send you those problems as well.
Okay, fine. Right. So right. Okay. You don't get PDF files for the.
I do for math, not for physics.
Okay. So if you have PDF file, you send that PDF file and also the questions you want to discuss,
Okay.
and then I'll
Okay.
get. If you have a prayer, this thing it'll be easier.
Okay.
Right. So anything else you want to discuss now?
Oh.
Okay. So you want to have a class tomorrow?
Tomorrow?
If you want, just WhatsApp me.
Oh, can I have your number then so then I can WhatsApp you?
Okay, 91482. So first you have to add the country code, right? Country code is 91.
Yes.
After that, 91482 55206.
9482.
First is country code. plus 91.
Yes, 9-1.
After that,
Yes.
another 91, 482,
Mhm.
55, 206.
Okay.
So totally 12 digits.
Yes, gotcha. Okay, let me see if it comes up. Did you get my text?
No, not it. Yes.
I said hello.
Yeah. 6404, right?
Yep.
Yeah, fine.
Okay.
So
I will message you. We can probably meet once more because I have some more physics works to do this weekend. Can we
yeah,
meet on Monday? I don't have school on Monday because it's a holiday for me. Does that work for
okay.
you?
Yeah, fine. So the previous day, can you send me the thing you want to discuss?
Yes, I will send you. I will work on it today and I will send you any questions I have by tonight. So then you have a day to look at them and come on Monday.
Yeah, sure. Okay, fine. Okay then.
Okay. Thank you.
Okay. Yeah, bye. We'll close, right?